Hi, welcome to the presentation. I'm Mazin. Good morning on behalf of Group 7. I have Nawaf with me, Nadia, and Atik. We'll be presenting on chapter 5, that is the assembly effect. We'll be talking about Netflix crowdsourcing and predictive analytics. This will be our agenda. We'll be going through these topics, have a look at those topics, and we'll be going through it in detail one by one. Martin Chabert and Martin Payot in 2008 won $1 million Netflix prize for analytical competition, who had absolutely no background in analytics. They beat Netflix on established recommendation capabilities by 10%. Contests such as Netflix Prize leverages competition spirit in scientific advancement. Almost in almost anyone in the world, old or small, tall or short, can participate by downloading the data, forming the model, and then submitting it. And yes, this was a winner takes all competition. Submission are subjectively compared. It's not the predictive model, but it's predictive score, which is used to determine the winner. Netflix price model predicts how a customer would rate a movie based on how he or she has rated other movies. True ratings are suppressed in the publicly posted evaluation data, so the submitters can't know exactly which examples they're getting right and which they're getting wrong at the time of submission. Netflix released to the public over 100 million ratings for about 5,000 customers, and these customers' names were anonymized. Model's ability to predict is all that matters, not the modeler's background, their experience, not even their degree. Whoever can come up with the solution that best handles the problem wins. They took the industry by storm despite their lack of experience or perhaps because of it. They were working in telecom industry as a software developer during the day, and by night they were working at home for 10 to 20 hours per week. You can see their photo on the left side. They were the heroes. Pragmatic theory is what they named their team. During the last final month of the competition, the team was often found to be in the top list. There is a different story which strongly resembles this. A company called Spaceship One. Spaceship One is an experimental air-launched rocket-powered aircraft with suborbital spaceflight capacity at a speed of 900 meters per second using a hybrid rocket motor. They were the first private-funded human spaceflight with a small team, short on resource, with a spending of only 25 million, put NASA to shame by doing so for much lower resource. Uh, for the next topic, I would ask Nawaf to take over. Thank you.
Thank you, Mazen. So, time and time it has been proven that you don't have to be a sophisticated data analyst to a world class predictive analytics model. Gone are the days that companies keep data to themselves in order to get competitive advantage. This really makes sense, right? So, in the past, company strategies were top secrets, and they made sure that the secrets were never put out, so the competitors doesn't know what exactly the company is doing. The complete data analysis and the prediction is done in-house with a data scientist. They have their complete data set. They allow the data scientist to do the prediction model, and the management take the decisions. However, there is abundant wealth in the market. These resources think out of the box, that mainly because they are not exposed to organizations' rules and regulations. So they don't have any limits, and the background of the person who is predicting is not relevant at all. What matters is whether the person, or for that matter the team, can figure out the best possible solution. End of the day, what really matters is quality of the work and the output, right? That allows the management to take the best decision for the organization moving forward. Companies have identified this, and there are quite a lot of competition in the market now. Outsource or freelancers can get into this competition and show their skills, and of course win hefty huge prizes. Best example is Netflix. They started a competition to solve their problem with a huge price tag. How cool is that? This attracts resources from different places around the globe. The best example of what I explained now is that the distribution of dark matters in the universe was predicted by glaciology. Moving on, I would like to elaborate further on how crowdsourcing has evolved. Apart from Netflix as an example that I explained earlier, there is a well-known platform for crowdsourcing, that is Kaggle. I'm sure all of you all have accessed Kaggle during this semester, and surely when we want to access the database, what comes to our mind is Kaggle. Uh, people are getting involved in this platform. Organizations as well as bright minds. Many organizations have realized that platforms such as Kaggle enables them to connect to bright minds easily. Because of that, it gives a different perspective for the entire problem that they have. And of course, it brings in different solutions as well. So, as a result of the popularity, there have been more awareness about data analytics, and more students are pursuing this path. By the way, the best outcomes for these platforms for me is that it enables to share knowledge among the community, as well as it allows people to learn out of things. So, moving on with the slides, see, we all agree competition is good for the organization. As long as the competition is healthy and controlled, the organization will benefit out of it. It obviously brings the best out of people and allows employees to showcase their talent and develop themselves in an organization, and obviously climb the ladder. Just imagine if the company can tap into the talent outside and create a competition. That's massive, right? It allows everybody outside the organization good resources to help the organization move forward. I mentioned in my previous slides that the crowdsourcing platforms enables to share knowledge and learn. This is a very unique situation because unlike organizations, these external resources seems to be very collaborative, and they are very happy to share and learn. This is a very good development for the data science community and for the entire community, of course. And for that matter, for the entire world, it enables the community to grow and hopefully make a better place for everybody to live.
Hello everyone, I'm Nadia Ismaili. I want to talk about the effect of ensemble method to improve our performance. The teams struggle to get the edge where other competitors they were achieving diminishing returns as they got closer to reaching 10% improvement. Two teams joined forces and won the Constance Annual Progress Prize of $50,000. Each team's model compensated for the weakness of the other, and the combination of the two models resulted in a considerable advancement. In terms of meta learning, we utilize ensemble method. We can obtain the optimum level of performance. We have seen that the difference between decision tree and random forest classifier machine learning algorithm is that random forest consists of a large number of individual decision trees that operate as an ensemble, a large number of uncorrelated trees operating as a committee which outperform any of individual trees. Uncorrelated models can produce ensemble prediction that are more accurate. The reason for this wonderful effect is that the trees protect each other from their individual errors. While some trees may be wrong, many other trees will be right. So as a group, the trees are able to move in the correct direction. We blend the techniques with machine learning algorithms and predictive models instead of digging and thinking intensely to compare different theories. and we train a new model that sits above the two existing models, like a manager. This new ensemble model can consider both models' predictions on a case-by-case basis. It can give more credence to model A rather than model B, or the other way around. So the ensemble model is trained to predict which cases are weak point for each component model. And the pooling models work together, provide the opportunity to develop the performance. A new team, the Ensemble, emerged from the alliance of over 20 teams combining their knowledge. The amounts of money won by the ensemble was divided between teams according to the ratio of their contribution to the improvement. Crowdsourcing competitions take advantage of each individual or each team could result in significant scientific innovation. It could lead much more devotion. After assessing and verifying the submissions by administrators at Netflix, it was held another undisclosed set of data to validate the submission and determine the final verdict. The result of Pragmatic and the ensemble's performance was so close to each other. The time of submission was the evaluation element. At the end of the competition, Pragmatic had uploaded its winning entry just 20 minutes before the ensemble, which means that just 20 minutes was worth $1 million. There is a concept that tells us the fish that ate the fish that ate the fish. So if you can't beat them, join them. The collective intelligence of a crowd emerges on many occasions. We should consider both overestimations and underestimations of people. If we assume that people guess too high as much as they guess too low, the average can overcome undesirable effect of errors in total judgments. And uniting can lead power. It means that pooling diverse skills can increase the rate of productivity. By coming together as a team, our limited capabilities and talents can overcome any problems in our team. And it's not important to find the smartest person. It's important to pull all diverse skills together to obtain the best result. Human minds are not the only things that can be effectively merged together. Sometimes it's very worthwhile to aggregate non-human crowds of predictive models.
Thank you, Nadia. Hello, everyone. This is Atik Kumar Vahora. According to Dean Abbott of Abbott Analytics, predictions can be improved by averaging the predictions of many. Like crowd of people, ensemble of predictive models benefit from collective intelligence effort. Each different models have their strengths and weaknesses, and each different models have their own predictive scores. These scores can be too high or too low, depending on the model. However, averaging scores from a mix of models can help reduce much of the error. It's also a move away from Occam's razor's principle, which is keep it simple. In this slide, I'll talk about bag of models. Leo Bremen developed a leading method for ensemble models called bagging. The way it operates is pretty self-evident. Make a bunch of models, a bag full, and then to make a prediction, have each model make it predictions and tally up the results. Each model gets to vote. Assembling components into a more complex, powerful structure is very essence of engineering. It is as similar as constructing big buildings or programming language for the operating system that runs your iPhone. Nobody can conceive the entire architecture at once. Tiered architecture makes it easier for everyone to understand. In this slide, I'll be talking about ensemble models in action. As per Anthony Goldblum, CEO of Kaggle, teams often use an ensemble model to win Kaggle contests. There are some examples of their commercial usage and development. which I'll be talking about now. IRS uses them for tax fraud detection, the Nature Conservancy to track the donations, Netflix to give movie recommendations to their users, Nokia Siemens to analyze drop calls and improve their services, US Department of Defense uses them to track down fraudulent government invoices, and US Special Forces to evaluate job performances and give raise to people who deserve them. Uh, Watson Watson is an AI that is currently used by IBM. That is also a good example of ensemble model in action. In this slide, I'll be talking about generalization. Ensemble appear to increase complexity. Since we are putting too many models together, it is complex. However, their ability to generalize better seems to violate the preference for simplicity summarized by Occam's razor. Ensemble remains robust even as they become increasingly complex. They're immune against overlearning. The one particular issue with ensemble is that when we are putting too many models together, there is a chance that there will be too much information and there will be too many errors, hence the overlearning. Measure of complexity is lower for an ensemble of models than for individual models. Since ensemble models exhibit less complex behavior, they are successful in robustly learning without overlearning. Thank you.